to discuss about the binomial distribution. It is also known as Bernoulli's distribution. Okay. So the name only says bi. Bi means two. Binomial means here some kind of trial that have got two kind of outcome we can expect. So that is known as binomial distribution. Let's get started. A random variable x which takes two values 0 and 1 with probabilities q and p respectively. So that is when p, that is x is equals to 1 is equals to p, means probability of s equals to 1 is p and probability of x is equals to 0 is q. Okay, and we know these two terms p and q very nicely, isn't it? P means probability of occurrence and q means probability of non-occurrence. Okay, so if x is equals to 1 means it is p, and when probability of x is equals to 0 means q. And this thing also we know, to determine q is equals to 1 minus p is called a Bernoulli variate and is said to have a Bernoulli distribution. Okay. Let a random experiment be performed repeatedly and the occurrence of an event in a trial be called a success and its non-occurrence a failure. Okay, so this sentence also we know very well. When any event, when it occurs, its occurrence of an event is known as success and non-occurrence is known as failure. Okay, means when you are tossing a coin, occurrence of head is success and non-occurrence of head is failure. Okay, consider a set of n independent Bernoulli trials in which the probability p of success in any trial is constant for each trial. Then q is equals to 1 minus p. So this will be the probability of failure in any trial. The probability of r successes and consequently n minus r failures in an independent trial in a specified order, say S, S, F, S, F, 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 S, so on and so forth up to F, S, F, where S represents success and F failure, is given by a compound probability theorem which is expressed by an equation is there. Okay. So what this fourth statement say is that, see, we know probability of success means P, or you can say probability of failure is Q. This thing we know, but the number of outcome, the number of trial is n, and in that n trial, whenever success occurs, we call it as R. Okay, probability of success is P, success is R. Okay, so number of trials are n, and in those n trials, the number of successes are R. So the number of failure will be obviously n minus R. Okay, so here one order of trial has been given, like probability of success, failure, success, and so on and so forth. It is given by probability of success multiplied by probability of success multiplied by, you can see, probability of failure, then probability of success multiplied by probability of failure, and so on and so forth. Okay, so whenever there is probability of success, we denote it as P, and whenever there is probability of failure, we denote as Q. And when we simplify, when we go on simplifying these things, matlab this success and failure, it occurs n number of times, and for those n number of times, when we try to simplify it, we got an equation as n combination R multiplied by P to the power of R multiplied by Q to the power of n minus R. Okay, so here we know all the terms over here. N means the number of trials, R means number of success in those trials, P means probability of success, Q means probability of failure, and n minus R means failure. Okay, now you will be exclaiming that n combination R, this NCR, n combination R, how to solve this? For solving this, we have got a simple equation. N combination R is equals to n factorial divided by R factorial multiplied by n minus R factorial. Okay, so you need to use this equation for calculation of n combination R, and you need to keep it in that previous equation, and you will get to know the binomial distribution. Okay, so you will get to know by a simple example. We will take an example and we will try to use both of these equations. Okay, so we will have an example. The result of treatment with an antibiotic is that an infection is either cured or not cured within 5 days. Okay, so here only in the first line only you got to know that we need to use binomial equation, because we have got just two options, cure or no cure. Okay, so within 5 days an antibiotic it should cure or it should not cure. Okay, we'll proceed. After performing 4 trials, it was found that outcome probability of cure is 0.75. Okay, so how many trials? We have got 4 trials. So value of n is 4, and in that, what is the outcome probability of cure? That is 0.75. So probability of success is 0.75. So P is 0.75. Okay, so we got so many things. We understood that it is a binomial distribution. We got the value of n, that is 4, and we got the value of p, that is 0.75. So suppose there are 5 possible outcomes, and those 5 possible outcomes are, first of all, within those 5 days no patients are getting cured. Second possibility is one patient is getting cured. Third possibility is 2 patients are getting cured. Fourth possibility is 3 patients are getting cured, and fifth possibility are 4 patients are getting cured. Okay, so we'll check out the probability for all these 5 options. Okay, so we'll have solution. First of all, we'll write all the given values. The value of n is 4, because in the question only it has been stated that n is 4. Okay, 4 trials are there. Okay, next, probability of success is 0.75. Okay, so in question itself it has been written, isn't it? P is 0.75. So when you got the value of P, you can calculate the value of Q. Q is non-occurrent, so 1 minus P. So you can say 0.25. So 0.25 chances of not getting cured. Okay, or you can say 75% of chances of cure and 25% chances of not getting cured. So we'll take first possibility. Okay, we are using these two equations. So the first possibility is no patients are getting cured. So when no patients are getting cured means, what is the value of R? What is the success? 0, isn't it? So the value of R will be 0. So next we'll be using this equation. P of 0. P of 0 means probability of 0 patients getting cured is equals to, for n combination R we'll be writing like this. Okay, 4 combination 0 multiplied by 0.75 to the power of 0 multiplied by 0.25 to the power of 4 minus 0 will be 4. Okay, next we'll try to solve this 4 combination R. Okay, 4 combination R. So we need to use this wala equation. Okay, factorial 4 divided by factorial 0 into 4 minus 0 factorial. Okay, so factorial 4 matlab 4 into 3 into 2 into 1 divided by factorial of 0 will be 1 multiplied by 4 minus 0 will be 4. So again 4 into 3 into 2 into 1, everything will get cancelled out and the answer will be 1. Okay, so 4 factorial 0 answer will be 1 multiplied by 0.75 to the power of 0. So anything to the power of 0 will get answer as 1 multiplied by 0.25 to the power of 4 is 0.0039. So the first no answer is 0.0039. So probability of no patients getting cured is 0.0039. Next, we'll have a second possibility, that is one patient is getting cured. So what is the success? R is equals to 1, right? Next, you keep no, you start using these equation. Probability of one patient getting cured is equals to 4 combination 1 multiplied by 0.75 to the power of 1 multiplied by 0.25 to the power of 4 minus 1. Okay, so go on solving it. So 4 combination 1 will solve over here. 4 factorial divided by factorial of 1 multiplied by 4 minus 1 factorial. Okay, so 4 into 3 into 1 and 4 minus 1 is 3. Everything gets cancelled. Our answer is 4. Okay, so keep here 0.75 to the power of 1 is 0.75. 0.25 to the power of 3 is 0.0156. So out of it we got 0.0468 answer. So probability of one patient to get cured is 0.0468. Next is 2 patients getting cured. So R value will be 2 because success is 2. Solve it. Factorial 4 divided by factorial 2 into 4 minus 2 factorial. Okay, So here, so 2 into 1 multiplied by 4 minus 2 will be 2. So this 4 gets cancelled out, 2 gets cancelled out. Answer is 3 into 2 is 6. So 4 combination 2 answer is 6 multiplied by 0.75 to the power of 2 is 0.562 multiplied by 0.25 square is 0.0625. So calculate it, you will get the answer 0.21. So the probability of 2 patients getting cured is 0.21. Next, probability of 3 patients getting cured. So our value is success is 3. Okay. So keep everything and go on solving. Okay. Answer over here will be 4. So 4 combination 3 answer is 4 multiplied by 0.75 to the power of 3 is 0.421 multiplied by 0.25 to the power of 1 will be obviously 0.25. So you got the answer 0.421. So probability of 3 patients getting cured is 0.421. Last is 4 patients getting cured. So the rate of success is 4. Okay. So probability of 4 patients getting cured is 4 combination 4 multiplied by 0.75 to the power of 4 multiplied by 0.25 to the power of 4 minus 4. Okay, simplify it. 4 combination 4 like this. So whenever such kind of thing occurs now, 4 combination 4 or 5 combination 5, the answer of this thing will be 1. That's it. Next 0.75 to the power of 4 is 0.316 and 0.25 to the power of 0 will be 1. Okay, anything to the power of 0 you should write 1. So the answer is 0.316. Okay, so probability of 4 patients getting cured is 0.316. Now you can write like this, a table of outcome, how many patients are getting cured and what all are their probability, and with the help of this binomial distribution you can represent it in a graphical manner also. Okay, so it's very nicely it is an understandable thing that how many people are getting cured and what all are the probability of those people to get cured. Okay, so this was all about today's video regarding binomial distribution. I hope you people found this video helpful. Thank you for watching.